That's one thing. The second issue is at IIT Tirupati, I used to teach. There used to be something called, uh, you know, warming up the mind. So some problems we'll discuss for 5 minutes. I'll post the problem. It is for you to think about and answer the problem. Not more than 5 minutes. And if you think that you want to warming up, then I'll find out problems in each lecture and give you one. Okay. The people in IIT Tirupati, they liked warming up because it really gives you some of the gaps that you have in your mind. Everything can't be taught in the class. So there are many gaps that you might have missed earlier. I will give you, few such problems if you think that you need it. The third thing is assignments. If you don't copy, I'll be very happy. Normally, the assignment problems, what I want to give you is only some 3-4 problems, not the whole sheet. I'll star the problems. So don't talk to your people, don't talk to your friends, but you can consult books. Assignments are meant to make sure that you are on your own feet, not on somebody else's thinking. Okay. Third thing is the mid-semester exam and end-semester exam. We have to give weightages. In IITs, the teachers assign the weightages, but there is a minimum of 40% for the end semester. You can't reduce that weightage. But other weightages, I can do it myself in IITs. I am not sure about NIT who fixes the weightages. I will ask your teachers there, find out what is the weightages. That's another issue. Another issue is you need to know references. So what I will do is I will try to send you the references, but there will be 1 or 2 main references that you have to really look into. As far as the lectures are concerned, I have sent you the notes. Why I have sent you the notes is that it is in PDF format. Second thing is it fits into your syllabus. Third thing is it has taken many of the ideas from many books and they have put here. I can't teach 6 books, right? So we have to take the best of the 6 books, and that is what is done by the author, Dancer. Dancer is a very good functional analyst, and he has wrote it for his students. Anyway, we can use that. So I use that for the online classes. Additional problems you can see from Lemier's book, Functional Analysis. You can look from Krasic's book, Functional Analysis. You have to be careful with Krasic's book. There could be some mistake. You can also see G.F. Simmons, Modern Algebra Anthropology. Whenever possible, I will send you you may not have the book. So what I will do is I will collect the material, make a PPT, and send you by mail. When I come in the end of August, I'll bring some of these books on a USB. Okay. I don't know who gave it to me. It's not good to send it on email. I'll tell you there when I meet you in NIT why we should not send it by mail. It's a copyright issue. Okay. Bring it by USB. Those who want to copy it, you copy it there. I'll be there for 3 days. Okay. Usual notations are used. I will send you the list of notations also. This is a preliminary, what is called the administrative matters. Now we will start with the course itself. I will stop the lectures by 9:55. Those who have class at 10, you can attend. Okay. First thing is you have to look into the syllabus. That I will show it to you in a moment. Important question comes to our mind. Why should we study functional analysis? And is there any strong reason why you should do it? So the idea is that we use it in several places. For example, advanced course on numerical analysis, you use it. Image processing, you can't do without functional analysis. Okay. Reconstruction, you can't do without functional analysis. Infinite data, big data, you use functional analysis. Why? Because big data cannot be done in finite dimension. What's the difference between finite dimension and infinite dimension? That's the question. The question is, in finite dimension, there is no question of any convergence because everything is finite sum. If you have a basis, it has a finite number of elements. Any element can be written as a finite sum. And how do you prove the existence of the finite sum? Use induction. Okay, n equal to 1 is obvious by the axioms of the vector space. Assume n equal to k, again you do the same axiom and then you show that it is true for n equal to k plus 1. And therefore it is true for any fixed n. So the summation I equal to 1 to n ak alpha k, if alpha k are the elements of the basis, this will exist. Have you noticed this or not? Did you ever see that why a finite sum should exist, that you should use mathematical induction? It depends on how it was taught in your linear algebra course. Okay. So that's the first point. Second point is that when you take an infinite dimensional thing, the summation alpha equal to 1 to n, ak alpha k, that n is the dimension of the space, that cannot be finite anymore if you are in infinite dimensional space. So the sum becomes alpha k equal to 1 to infinity, alpha k and ak. The moment you have an infinite sum, you have to prove the convergence. What do you mean by convergence? How do you make sense of that? You write something, but what do you understand by that is more important than what you write. You can't write it blindly. Okay, that's the first thing. Therefore, you have to go to the usual, real analysis. You have a summation an summation n equal to infinity. You take the partial sum. Look at the limit of Sn going to infinity. That means you should know convergence of sequences and series before you start function analysis. But where? Where do you see the convergence of sequences and series? Is it in a place where there is a metric or no? No, we are going to look into only convergence of sequences and series in metric spaces. Why metric? That gives you a sense of the length. So you can talk about something going to small, something is large, something is closer to something else. Then you can define open sets, closed sets, etc. What I understand is that you have already done metric spaces. Am I right? Do you want a revision of the metric spaces?
Yes, sir. Quick revision, sir.
Okay. Because every alternate lectures we are going to use metric space property. Therefore, it is better you revise the knowledge. I am not saying you don't have the knowledge. I am only saying revise it. If you don't know, you can as well learn it. But I won't be able to give the proofs. Proofs you look into it further. So what is functional analysis? It is going from finite dimensional vector spaces to infinite dimensional vector spaces. Since convergence is needed, you need a topology. Therefore, you do it on a metric space to start with. Somewhere else, we can also do without a metric space also. I will let you know on that when it comes. Weak convergence cannot be done in metric spaces. Okay. So simple example is take set of all polynomials. Okay. The basis is 1x, x squared, x cubed, etc., etc., x raised to n dot dot. That's not finite dimensional, right? So if you take a function like exponential x, which is summation, okay, uh, x raised to n divided by n factorial. That's a linear combination of x squared, x cubed, x raised. So you have to prove the convergence of this series, without which exponential will not make sense. That is what is done in the real analysis. Okay, I'm giving you a simple example. That the basis elements here for the set of all polynomials as a vector space. The basis is 1x, x squared, x raised to n, etc., etc. That is not a finite set. It's a countable set. Same story with C01. You can't write an element of C01 with whatever the basis that you take for C01. Can you show that C01 is, you know C01, no? All continuous functions from the closed interval 0, 1 to r. It's a vector space, usual pointwise addition. Is it finite dimensional or infinite dimensional? Can you answer quickly? Anybody? C01, is it finite dimensional vector space or infinite dimensional vector space? Do you want the lectures to be interactive or not? Huh?
Finite dimensions.
Huh? Pardon? ME005. What did you say? Hello?
Finite dimensions.
Finite? Finite or infinite?
May I have your attention, please?
Do you want the lectures to be interactive or not? Huh?
Actually, sir, I don't sure about the correct answer. That's why.
Huh?
Sir, I don't know correct answer, sir. That's why I'm thinking. Or it is
Okay.
finite and infinite.
Somebody said MA005. It is
Sir,
linear.
he said, sir, finite dimension.
But if he says finite dimension, he has to prove it. No. You can't say something and then get away with it, right?
Okay, yes, sir.
Okay. If it is finite dimension, every basis should have finite number of elements, right?
Yes, sir.
Okay. 1x, x squared, x raised to n dot dot dot. These elements are in C01. They are in C01, right? They
Yes,
are all
sir.
continuous functions. Are they
Yes,
infinite number?
yes, sir.
Yeah. Are they linearly independent?
Yes, sir.
So how can there be infinite number of elements in a finite dimension?
Yes, sir. Then it is infinite dimension.
Somebody said that.
Yes, sir.
So this is what I am trying to put it across to you. You have to freshen up your MA005. What is his name?
Ganpati. Ganpati, sir.
Uh,
May I have your attention, please?
so this is something which you have to understand, and that is why I said it is better that you revise your linear algebra. Okay, if you take a vector space of dimension n or any vector space, will it have a basis?
Yes, sir.
How do you prove? Hey, any question that anybody asks you, if you say some answer, you have to justify it. How do you show that every vector space has a basis? Okay, these are the sort of questions which I wanted you to do it, or I want to do it as what is called the brainstorm it.
Because sir, base any vector in basis means sir to which we generate the whole vector space. Then if we can generate any
No, no,
vector
no,
space,
no. I don't want all these stories. Don't tell me if we can generate and give me. I give you a vector space. Generate and give me. You should not put back the answer on something else. You have to give a full proof. Shall I do it when I come in the month end?
yes sir.
It's not as simple as what you think. Huh? Okay. All right. So these are the sort of questions, which. So before we start, I just want to tell you what is that. Uh, we are going to study. So you should know what is called the syllabus. So we will look at the syllabus. Okay. Why it is not sharing here? I don't know. Is it shared?
No sir, till not.
Why it is not sharing then? Some issue here. Huh? No?
No sir.
No?
Yes sir, yes sir. Now it's sharing.
So the first part of the 14 lectures.